Hey, we're group 13 and we did the magnetic levitator. And our group members are Jacob McCannon, Ken Park, and then Khalid on video, and then I'm Parker Hinson, and this is Caleb Wiff, and he's gonna take it from here.
All right, so like you said, we did the magnetic levitator. Unfortunately, we were ultimately unsuccessful. We first started with trying to do a PD control using a small LiDAR sensor, kind of like this guy right here. This particular one has a range of 0 to 100 millimeters, but we started with one that had a range of 0 to 1,000. And we did mention in a class a couple times, that really didn't have the resolution we needed for this particular project, and that's why we ended up switching to the 0 to 100 range sensor. Unfortunately, we just couldn't get it to jive with our code. This is I2C sensor, which makes it a little tougher to mess with compared to analog. At least for me, anyway, for us, for our expertise on Arduino. So we ended up moving away from that and trying to go with analog sensors, the Hall sensors. Part of the reason we wanted to try distance sensors is because we could use just a straight ferrous object and not have to try to levitate a permanent magnet. But like I said, we were ultimately unsuccessful. So we went the route with Hall sensors, and we started out with using one on the top and one on the bottom, and trying to use PD control. So one on the top and one on the bottom would be able to give us a comparison between the two. And then if you want to walk over here. So this is our setup right here. Here's our coil. We've got 1,000 turns of 22 AWG wire. Here's our power supply powering our coil. This is an old Xbox 360 controller that will push 12 volts, and it can push as much as 10 amps. So this was more than sufficient for our needs. This is the actual pinout. You have a bunch of wires here, but you can get either 5 volts or 12 volts out of this. Like I said, we tried the 2 Hall sensor route, but we weren't getting it to work. We're actually able to set up 3 potentiometers right here. One could alter KD, one could alter KP, and one the set point. And they were all working, spitting out wonderful looking values in our serial monitor. But for whatever reason, it just wouldn't modulate our coil. I'm not sure why. Whatever code we had simply refused to talk to the coil. But so we ended up, some other groups had some success with simple P control using one Hall sensor. So we put one Hall sensor on the bottom of the coil right here, and then we wired up some switches here to increase and decrease our set point, and that was our only variable, is the set point, so basic proportional control. We had some measures of success with that. In fact, right here, we'll show you some footage of us very nearly levitating an object. So you can see there, we didn't quite get it. We got very close, but we just weren't there. Now here are some of the different objects we tried to levitate. We tried different weights and sizes. We figured that more weight equals better damping, or more damping due to mass. Our best luck was with this small object, but we got very, very close with this large bearing, actually. But in fact, our digital switch, we had one position click where it would fall out, and then one position where it would snap to the magnet. There was just that in-between value is what we needed to get it to float. But right now I'll hook everything up and I'll kind of show you how it looked. So if you'll come over here, you can see this is our serial monitor for our Arduino. This value right here is our set point, and Parker's gonna change it a little bit, and you'll be able to see. It's probably hard to see on from the computer, but he's actually moving the set point up right now. All right, now I was about to show you us very nearly levitating this big bearing like I talked about earlier, but I hooked it up and turned it on and it wasn't working, and we discovered that we had broken yet another Hall sensor. So I had padded this Hall sensor with a small piece of foam, but apparently that wasn't enough. So we must have snatched one of our weights a little too hard and just smashed our Hall sensor. So that makes 3 Hall sensors we've broken like that now. Broken Hall sensor, bricked Arduino, and we're out of cops.